Okay, last but not least, if you have molecules with 6 pairs of electron around the central atom. Okay, the first example I want to show you is SF6. Again, SF6 Lewis structure looks more or less like this. Alright, let's consider the number of electron around the central atom. We have 1, 2, 3, 4, 5, 6 pairs of electron around the central atom. Therefore, it will assume the shape of octahedral. So this is how we are going to draw octahedral. If you still remember, we are going to draw as if it has the bonding from all angle, three-dimensional, depan, belakang, kiri, kanan, atas, bawah. So this will assume, this will make a bond angle 90 degree. Alright, so how do we explain this? Okay, again, we start with number of electron pairs around the central atom, which is 6 pairs of electron. And all of them are bonding pairs electron. So the repulsion is equal. Therefore, it will take the shape of octahedral, which makes 90 degree between each other. Alright, moving on to the second example that I want to show you, which is BRF5. Okay, BRF5, we have this Lewis structure of BRF5. Again, if you consider the number of electrons around the central atom, you will see that it has 6 pairs of electron. However, one of them is lone pair electron, while the rest is bonding pair electron lah. So it will take the shape of square pyramidal. So we can draw square pyramidal like this. Okay, and the angle will be less than 90 between each other. Now, because of the presence of lone pair electron, okay, we will have different molecular geometry and also different bond angle than the one that we have for SF6. Okay, so we still have 6 pairs of electron, but being specific, one of them is lone pair, the other 5 is bonding pair electron. And because of the presence of lone pair, the repulsion is not equal, because repulsion of lone pair and bonding pair are much stronger than bonding pair with bonding pair. Therefore, the electron arrangement will be the same, which is octahedral. However, it will have different molecular geometry, which is square pyramidal, and the angle will be less than 90. Okay, last example is if we have ClF4 molecule, where we have more or less like this is the Lewis structure. Okay, again, if you look at the central atom, it has 1, 2, 3, 4, 5, 6 pairs of electron, but 2 of them is lone pair electron. So of course you will have a different molecular geometry for this molecule. It will take the shape of square planar. So we are going to draw square planar like this. Since we have two pairs of lone pair electron but at the opposite direction, so actually the bonding pair will becomes equal back because it is being pushed equally from the same from the opposite direction, which will make it becomes 90 degree again. Okay, so the point that we need to stress is, again, it has 6 pairs of electron. Being specific, 2 of them is lone pair electron, while another 4 is bonding pair electron. So of course, it will affect the repulsion now that it has 2 lone pairs electrons. So the repulsion will be much greater between lone pair electron than lone pair bonding pair electron, and of course lone pair bonding pair electron have much greater repulsion than bonding pair electron. So because of this, the electron arrangement is still the same, which is octahedral. The molecular geometry now becomes square planar, and the angle will become 90 degree.